I will show you how to analyze the data that you've collected using the gyroscope as the duct tape roll with the iOLab device inside it rolls down an inclined plane, gets launched off the edge of the table as a projectile, and then subsequently falls onto the pillow on the floor. So here I've gotten rid of the x and the y-axis data because, as we mentioned earlier, those two rotations about the x and the z axes are consistent with 0, so we need not include those in our analysis. So the only thing of interest is the rotation of the device about the about the y-axis. So you can notice here that there are two portions to this data. There is a linear portion here where the rotational rate increases linearly with time and reaches a maximum, and thereafter it flatlines for some amount of time, and this portion here represents the time of flight when the projectile was in the air. And the launch speed off the edge of the table is given by the final velocity after it accelerates down the inclined plane. So what we will do is we will zoom in on this section here because we're interested in the time of flight. So let me select that portion over here. So you now have here the time of flight, which, as you can see for my setup, is about 0.36 seconds. And the average value for the rotational rate here, which is pretty much constant, is about 13.82 radians per second measured about the y-axis. So that gives you the final rotational velocity of the device just before it got launched from the edge of the table. So this rotational velocity is what you will employ for determining the linear velocity just prior to launch.